All right, for part 2 of this video series on unit conversions, we're going to finish off these last 3 problems on this number 8 on the worksheet. Again, using the chart up top to come up with our conversion factors for each one of these conversions. If you're wondering how I got these little road maps that I have for each problem in pink, then make sure you go back and watch part 1 of this little mini lecture on this technique. So moving right forward with this, remember that these roadmaps tell me the conversions that I'm going to need to do to convert the number I'm starting with. So for this problem, letter B, that's going to be 9.3 nanograms that I'm starting with, and I'm trying to convert that into milligrams. And so with my roadmap, I'm noting here that I want to convert the nanograms into grams first, and then into milligrams. And I do this going through the base unit because I find it easiest to come up with my conversion factors when I have them related back to the base unit. And I did that up here for this first problem, which was part of the part 1 video. I'm going to do this again for all 3 of these remaining problems. So the way I solved the last problem though, I actually started off by thinking about what units I'm going to need. And I encourage you, if you are someone who is new to this method and you are really uncomfortable with it, then take stock of the individual steps I'm using to solve these problems and try to start off by using those steps, because it will really help you start to get comfortable with this method. And then once you're comfortable with it, you can obviously kind of go through these a little faster without having to break it down step by step the way that I'm doing it. But I highly encourage you, if you need that structure, if you need that specific step-by-step procedure of how to go about this, then please, try to emulate what I'm doing here. So I know I'm starting with my 9.3 nanograms. I know that I'm interpreting that number as being in the numerator. So if I want to basically eliminate the nanograms and convert it into grams, because that's my first step, then that means that I need grams on the top because my desired unit should be on top in this case, and nanograms on the bottom so that those nanograms are going to cancel out. So remember, top and bottom here are going to cancel out. Now I'm not putting any numbers in yet because I haven't decided yet how these units are related to each other, but I can put the units in their appropriate places right now just based off of how I'm trying to do this conversion, just based off the rules of how these units cancel out. Now, after this first step, if I cancel out nanograms and I'm left with grams, then going from grams to milligrams, I now want to cancel out the grams. So in the next conversion factor, I need grams on the bottom, and I want to end up with milligrams, so I want milligrams on the top. And so we note here how grams are going to cancel out, and we're going to be left with milligrams at the end, which is the desired unit we're looking for. So now to fill in the numbers that are going to go in the numerator and the denominator. The way I come up with these numbers is I always start, for each association that I have here, I start with the unit that has the prefix, and I say, if I have 1 nanogram, what is that going to be equal to in grams? And in order to determine that, I come up here to the chart and I recognize that nano is equal to 10 to the negative 9th. That's the factor. So I'm going to swap out the nano prefix with times 10 to the negative 9th. So I keep the 1, I swap out nano with times 10 to the negative 9th, and then I keep the base unit grams. And so again, note, nano is being swapped out with times 10 to the negative 9th. To reiterate this again, I know that for my second conversion factor, I'm going to need to go from grams to milligrams. So the unit with the prefix is the milligrams. So I say I have 1 milligram. What is that in grams? If I come up here to milli, I note that that is 10 to the negative 3rd. So 1 times 10 to the negative 3rd grams should be equal to 1 milligram. So again, swapping out the prefix milli with the factor that is equivalent to milli. Okay, now that I have these equivalence statements, I can very clearly see what number is associated with each unit. And I highly encourage you, again, when you're getting started here, to write out these conversion factors, because one of the most common mistakes people make is putting the number with the wrong unit. So, if we want to plug in this nanogram to gram conversion factor, I need to keep the 1 with the nanogram, which means 1 is going to go on the bottom here. And I need to keep the 1 times 10 to the negative 9th with the grams. It would not be correct to put these in the opposite positions. I can't tell you how many times I've seen the setup like this, and I've gone, okay, well, they have their units in the right places, but the number they've associated with their unit doesn't make sense. And you can always kind of think about this rationally as well, because does it make sense that 1 gram should be equal to 1 times 10 to the negative 9th nanograms? Let's think about what that means, right? 1 times 10 to the negative 9th is a number smaller than 1. So if you're saying you have 1 times 10 to the negative 9th nanograms, you're saying you have less than a nanogram. And so that's basically saying here that 1 gram is equal to something less than a nanogram, when we know that that's not true, because up here in this chart, we know that nanograms are actually a smaller unit than grams. And so if you have 1 nanogram, you actually only have part of a gram, not the other way around. So note here that if we set up the numbers correctly, with the way that they're associated in this equivalence statement, with having 1 nanogram on the bottom and 1 times 10 to the 9th grams on the top, that this does make sense, because 1 nanogram is less than a gram, and so the way these two are equal to each other is that you only have part of a gram when you have 1 nanogram. So that's another way to kind of double check your work as you go. Now moving over here to the next conversion factor, paying attention to where my units are, and paying attention to the equivalence statement that I wrote out, I can see that I should have a 1 associated with the milligram, so I put a 1 there, and I have 1 times 10 to the negative 3rd associated with the grams. So 1 times 10 to the negative 3rd. So again, if I'm typing this into my calculator, I'm going to do 9.3 times 1 times 10 to the negative 9th divided by 1 times 10 to the negative 3rd. And if I punch that all in as given, I'm going to get 9.3 times 10 to the negative 6th milligrams as my answer. Again, I can pay attention to what makes sense here for the units. I'm starting with 9.3 nanograms, which is a very, very small mass, right? Nanograms are a very, very tiny mass. I'm converting this into milligrams. Milligrams are a larger mass than nanograms. So it makes sense that the 9.3 is changing into something smaller than 9.3, right? 9.3 times 10 to the negative 6 is a smaller number than 9.3. And that makes sense because if I have nanograms that I'm starting with and I'm trying to express this in terms of milligrams, I'm going to have less than 1 milligram, right? Because a milligram is larger than a nanogram. So even though I have many nanograms here, I have 9.3 nanograms, I still have less than a milligram when I can express this number in milligrams. So my final value here should be 9.3 times 10 to the negative 6 milligrams. All right, moving on to the next one. So same process here. I'm going to go through this one a little bit faster. So 105 microliters. I want to take this to liters first. So that means I'm going to have liters on the top because that's what I want to end up with, and microliters on the bottom so that those units are going to cancel out. Then I want to go from liters to megaliters. So I want to put liters on the bottom and megaliters on the top because I want the liters to now cancel out and I want to end up with megaliters. Now I want to write out my equivalence statements for these things. So I have microliters to liters. So I start with the unit with a prefix. So 1 microliter is going to be equal to, if I come up here and look for micro, I can see micro is 10 to the negative 6th. So I swap out the micro with times 10 to the negative 6th liters. Again, swapping out micro with what its factor is. The next one is the liters to megaliters conversion. So I want to start with the unit that has the prefix, 1 megaliter. I'm going to come up here and look at what mega stands for. Mega stands for 10 to the 6th. So I'm going to multiply this by 10 to the 6th to express it in liters. Again, mega being swapped out with the scientific notation or the factor that is equivalent to mega. All right, once I have my equivalence statements, I can now see how the numbers are associated with the units and I can fill them in properly. So for the first one, liters and microliters, I look at my first equivalence statement. I see that I have a 1 in front of the microliters. I have a 1 times 10 to the negative 6th in front of the liters. For the next one, I have a 1 in front of the megaliters. I have a, whoops, sorry about that. I have a 1 times 10 to the 6th in front of the liters. So note here, I'm going to be multiplying the 105 by 1 times 10 to the negative 6th, and then dividing by 1 times 10 to the positive 6th. And if I do this, I'm going to get 1.05 times 10 to the negative 10th megaliters. So my final answer here would be 1.05 times 10 to the negative 10th megaliters. Notice again how you're thinking about the units. Micro, as we can see up here, is a small unit. So you only have, less than a liter basically when you have microliters, right? So this 105 microliters is still less than a liter. When we're converting into megaliters, megaliters is a large unit. It represents many liters. So if we're converting from a small unit to a large unit, it makes sense that our number is going to get smaller because 105 microliters is a very small volume. And if we express it in terms of a large volume, we're only going to have a portion of that large unit for volume. All right, moving on to the last one here. So we've got 1.21 gigawatts. Those of you that recognize that reference, or maybe I should say 1.21 gigawatts as they are pronounced in that movie. So for this conversion, I am going from gigawatts to watts. So I want to have watts on the top, gigawatts on the bottom. I'm going from then watts into milliwatts. So I'm going to have watts on the bottom and milliwatts on the top. Again, notice how I'm setting these up so that my unit that I don't want cancels out. And I should be ending up with the unit that I do want at the very end of this. I got to get my conversion factors from my equivalence statements. So I know I need gigawatts to watts. So that means I need to figure out what 1 gigawatt is equal to in watts. Well, if I come up here to giga, I can see that giga is equal to 10 to the 9th. So 1 gigawatt is 1 times 10 to the 9th watts. If I want to go from watts to milliwatts, then I need to know what 1 milliwatt equals in terms of watts. So I come up here to milli and note that that is 10 to the negative 3rd. So I know that 1 milliwatt, I'm going to swap out the milli and replace it with times 10 to the negative 3rd watts. So again, giga gets swapped out with times 10 to the 9th because that's the factor it's associated with. Milli gets swapped out with times 10 to the negative 3rd because that's the factor it's associated with. Now that I have my equivalence statements, I can see how the numbers are associated with the units in these conversion factors. So for the first conversion factor, I have a 1 in front of the gigawatts, and I have a 1 times 10 to the 9th in front of the watts. For the second equivalence statement, or second conversion factor, I have a 1 in front of my milliwatts, and I have a 1 times 10 to the negative 3rd in front of the watts. So if I type this into my calculator, I'm going to take 1.21 times 1 times 10 to the 9th divided by 1 times 10 to the negative 3rd. And when you type that all in, you get 1.21 times 10 to the 12th milliwatts as your final answer. So I'm going to report that, oops, not negative 12, positive 12 milliwatts. And again, I'm going to think about whether or not that makes sense, because this time I'm starting with a very large unit, right? Gigawatts is a very, very large unit. It's expressing many, many watts that we have, whereas milliwatts is a very, very small unit that represents less than 1 watt. So if I have many, many, many watts, right? I have 1.21 gigawatts, which is a huge value, and I try to convert that into a unit that is something that's very small, then I should end up with a much larger number at the end, right? Because there's lots of milliwatts that are going to be contained inside 1 gigawatt, right? And that's just how those units are related to each other. Okay, I hope this was helpful in terms of recognizing how to do these prefix unit conversions. A lot of this is going to apply with regular dimensional analysis as well. So a lot of the things I talked about are useful for the problems that are going to follow in this worksheet, and there will be some separate videos on those problems. Also, if you are not getting these correct numbers for your answers, it's most likely, and your setup is correct, it's most likely because you're not typing things into your calculator correctly. So I'm going to record a video on how to use your calculator correctly with scientific notation in calculations, and I highly encourage you to watch it if you are struggling with this and you don't know why, because a lot of people appear to not know how to properly use their calculators when you're dealing with scientific notation.